This is part 1 of the Chapter 10 review. And in this set of problems, we have this circle and several segments, lines, rays. We are to tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle P. So let's begin. Number 1. PK, that's segment PK. Segment PK goes from the center to a point on the circle. That's the definition of a radius. Two, segment NM. Segment NM is a segment that has its endpoints on the circle. That is the definition of a chord. 3, ray JL. So ray JL, it intersects the circle at exactly one point. That is a tangent. 4, segment KN. Segment KN is a chord because it has its endpoints on the circle, but it's a chord that passes through the center and includes the center, and so that is the definition of a diameter. 5, line NL. Line NL it contains segment NL, it contains a chord, but it goes on forever, and it intersects the circle at exactly 2 points, so that is a secant. And 6, PN. Segment PN, again, that is a segment with one endpoint as the center and another endpoint on the circle. That's a radius. Okay, let's move on to the next set of problems. In problems 7 and 8, we're asked to tell whether the common tangent is internal or external. An internal tangent is an internal common tangent is a tangent that would cross a segment. Imagine there's a segment connecting the midpoints, the centers of both of those circles. If the tangent crosses that segment, then that's considered an internal tangent. Since this tangent crosses that imaginary segment, it's an internal segment. For number 8, if we drew a segment from here to here, you could clearly see that this line would not intersect that segment. Now, keep in mind, we're not talking about a line through these 2 points. If there was a line, we don't know that this is parallel to this, so at some point this tangent may intersect the line through these 2 points, but that's not what describes internal and external common tangents. It's simply a segment connecting the centers of the circles. So since the segment begins here and ends here, it clearly does not intersect this tangent, so this is an external tangent. So for 7, it's internal, and for 8, it's external. All right, let's move on to the next set of problems. In problem 9, we're looking to use the external tangent congruence theorem. That is, if 2 tangents to a circle intersect at a common point outside the circle, then those tangent segments are congruent. And so the way we solve this one is, for 9, we say 9a squared minus 30 equals 3a. This is a quadratic equation, so we're going to move everything to one side of the equal sign and set this equal to 0. So we have 9a squared. We're going to subtract 3a minus 3a minus 30 equals 0. Now we have a common factor here of 3, so we're going to pull that out. That gives us 3a squared minus a minus 10 equals 0. Now we have to see if we can factor this quadratic. So this is 3 times, and if it is factorable, there should be 2 linear factors. One has to be 3a and a. So the product of these 2 factors has to equal this piece. I know if this sign is negative, these signs are different. So let's make this one positive and this one negative. This is just a guess. And then we need products, factors of 10 that add up to a with this combination. And it's a roll of the dice. It's really difficult to tell which one goes where. So let's just do 2 and 5. 2 times 5 is 10. Let's just see how this works out. So we have 3a squared minus 15 plus 2. Well, that's definitely not 1. So that's not going to work. So that was wrong. I'm going to go ahead and just get rid of this and then put a 5 here and a 2 here. So this is 3a squared minus 6a plus 5a. That gives me the negative a minus 10. So these are the 2 factors. So we know that 3a, one of the factors is 3a plus 5 equals 0, and a minus 2 equals 0. Well, using the zero product rule, if 3a plus 5 equals 0, then 3a equals negative 5, a equals negative 5 thirds. That's not going to work because that would make this segment negative, so this is not a valid factor. Then we go to the next one, a minus 2 equals 0, therefore a equals 2. That one would work. And that's a valid value for that variable. All right, let's go to number 10. In number 10, we have the same idea. We just have to set these two equal to each other. 2c squared plus 9c plus 6 equals 9c plus 14. Now when we move this to the other side, these two cancel out. And looks like we can just bring the terms to either side and solve by square roots. So 2c squared plus 6 equals 14. Let's subtract 6. 2c squared equals 8. C squared equals, we're going to divide by 2, 4. Therefore, C equals plus or minus 4. Again, we can probably disregard, we can disregard this negative 4, because when we put a negative 4 in here, 9 times 4 is 36. That's a negative, so that can't work. So it can't be the negative, so the result is C equals 4. All right, and then 11. Now this problem is using the tangents of a circle theorem that says a line is tangent to a circle if it's perpendicular to a radius at its endpoint. So if this is tangent and we're going to assume that it's tangent, well, it says that y and z are points of tangency. So this is a point of tangency, therefore this is a right angle. That makes this a right triangle. So we can use Pythagorean theorem here. 9 squared plus r squared equals, this is the hypotenuse, which is 3 plus r. 3 plus r squared. So 9 squared plus r squared equals. The expansion of this binomial, the squared binomial, is this piece squared, this times 2, and that piece squared. Now we can see that the r squareds cancel out, and we're left with 9 squared equals 9 plus 6r. This is 81. We're going to subtract 9 from 81, which is 72, equals 6r divided by 6. 12 equals r. Oops, that's an r. And that solves problems 9 through 11. Let's move on to the next set of problems. In this problem, we're asked to determine if AB is tangent to circle C. The way that this would be tangent is if this was a right angle. The only way this is going to be a right angle is if this length is a hypotenuse and this are legs that satisfy the Pythagorean theorem. Now this looks kind of suspect that it might be a Pythagorean triple. So we can see that one radius is 10, so this whole side is 20. And my side lengths here are going to be 52, 48, and 20. If I divide these all by 2, that's 26, 24, and 10. If I divide them again, I get 13, 12, and 5. Yes, in fact, 5, 12, 13. It's a 5, 12, 13 right triangle. So this is a right triangle. This is the longest side. Now this is a point of interest. If they had swapped these and made this piece 48 and this 52, even though it would look like a Pythagorean triple over here, we can clearly see the right angle must be here, which has to be opposite the hypotenuse. So if this was 48 and this was 52, this couldn't have been the right angle because this side would have been longest, not this side. So in either case, this is a right triangle. You can check the result by simply saying 52 squared and then 48 squared plus 10 squared. And if you put these in your calculator, you get 2704, and this is 2704, and the sign is equals. So by the converse of the Pythagorean theorem, this is a right triangle. So in either way you slice it, it is tangent. So this is tangent to this. AB is a tangent to the circle. Let's move on to the next problem. In this set of problems, we're given a circle and we're given two central angles, and we're asked to use the diagram to find the measure of the indicated arcs. Now, my suggestion would be to just fill in all the information you can find out before you answer the questions. Makes it a lot easier sometimes. So if we take a look at this, we can clearly see that LN is a diameter. If LN is a diameter, then LKN is a semicircle. And if LKN is a semicircle, then it equals 180 degrees. And understand that the measure of a central angle is the measure of its intercepted arc. So this angle is 100, this arc is 100. That makes this angle 80. That makes this arc 80. So this arc is 100. If this is 120, this arc is 120. And if this is 120, this has to be 60. That makes this 60. Now we can go ahead and answer these questions. 13 is arc KL. Arc KL is 100. 14, LM. Arc LM is 60. 15, KM. Arc KM is 100 plus 60. So that's 160. And 16, KN. KN is 80. So again, it's a lot easier to just fill in all the pieces you can determine and then go off and answer the questions that are posed to you. It's generally easier to do that. All right. Well, in the next part, we'll continue on with problem 17.